Let me continue the agenda. If you have more questions to Professor, please.
Давайте продовжувати. Йти по нашому плану. Please stick to the agenda
Let me
and
give a
time
floor
constraints.
to Professor Libovka. The title
Now,
of his
Professor
presentation.
Libovka will talk about.
I want to. Thank you very much for opportunity to make this presentation.
Дякую за нагоду зробити цю презентацію. Це від трьох груп презентацій, які представлені тут. І хочу сказати, наша тема – це розробка методів комплексної характеризації нанокомпонентів. Це гібриди нанотрубки всередині жидких кристалів та наноматеріалів. Це найбільш гаряча тема наукових досліджень. І практичне застосування. Це новий продукт.
And present here the different application. It may include liquid crystalline devices, a new type of switches, microelectronic devices, sensor, and many other type of devices. I want to say about this product. It's a new kind of product. It may be have application in display in electro-optic industry, photonic and metamaterial industry, and as a sensor. Useful effects and properties that were revealed for this products. It's electro-optic and memory effects, decreasing of rotation, viscosity, increasing of switching speed, increasing of dielectric anisotropy, decreasing of Frederick threshold, and suppression of ionic field screening. What are the materials? It's a commercial liquid crystalline compound. For example, it's a cholesteric, it's typical pneumatics, but improvements are still needed for the facing new technological trends. Carbon nanotubes, single and multi-walls, and inorganic platelets, natural and synthetic. The problem with the nanocomposites, the nanotube suspension are aggregated and unstable, and we need for the practical implementation the stable dispersion. For example, here I present freshly prepared nanotube suspension and incubated suspension. You see that it changes with the time. Our achievement. We had observed the positive temperature coefficient of resistivity. For example, you can observe here the jump in conductivity near the solid pneumatic transition. For many liquid crystalline systems, we had observed also the similar behavior near the isotropic to the liquid crystalline state. It's maybe regulated in external magnetic or electric field, so it can be used as a switcher. Next achievement, we use the different mixtures of the liquid crystalline compound in order to obtain a highly dispersed system. For example, in the cholesteric liquid crystals, we have as a good solvent, and nanotubes are well dispersed inside that. In the 5CB, we have a well-aggregated system. Regulating the components of this and this system, we can obtain some system with a highly dispersed nanotubes. Another sense, it's mixtures of nanotube with organo-modified platelets. For example, the laponite or the montmorillonite. We can observe the highly dispersed system with a very good memory, electro-optic memory effects. And another sense, it's an effective memory. For example, when we apply electric field, we can transfer this system in such light state, but after field off, we can conserve this lighting state. Moreover, applying electric field, we can observe such oriented system. Moreover, we can obtain after some threshold field a well-dispersed system. How it works. It includes two steps: evaluation and optimizing. Evaluation consists of estimation of microstructure, temperature, electrical conductivity, and other properties. Optimizing consists on optimizing of the content of the composite, content of the liquid crystalline solvents, threshold switch and Friedrich voltage, self-reflection properties, etc. Intellectual properties. Here we present only one patent, liquid crystalline composites in motor reproduction, and more than 20 articles published during this period in these journals. Peculiarities. Innovation. The main innovation is based on use of the carbon nanotube because of their extremely anisotropic shape and exceptional anisotropic properties, making them as a powerful dopant for the adjusting of anisotropic properties of the liquid crystal. In fact, we have here two combination of two anisotropic properties, liquid crystals and nanotubes. Advantages. We observed new different effects: PTC, switch and electrical memory, enhanced dispersion with potential for liquid crystalline display technology and sensor application, new mixtures of nanotubes and different types of organo-modified platelets, new mixtures of bad and good solvents, and possibility of manipulation and dispersion of nanotubes by external electric fields. It may be exploited for the highly aggregated systems. Economic value. The composites with attractive electro-optical characteristics and high stability and aggregation are prepared using original methods. The relatively simple methods are used. They don't require special sophisticated equipment, application of complex chemical, etc. These materials can be produced by using the local reagents. Nanotube produced in Ukraine, organo-modified plates are produced in our chemical laboratories, and we have all components. Characterization of products can be carried out using standard instruments. Proposal. A liquid crystal application currently worth more than 16 billion per year. It's developed well dispersed, and stable nanocomposites on the base of nanotubes and platelets have a good potential for improvement of current technologies. We can propose different kinds of new nanomaterials, functionalization of existing system, the liquid crystalline electrode materials and alignment layer, and new or modified switch and mode. Networks. Nowadays, Ukraine network with different countries: France, Germany, UK, USA, Taiwan, Korea, Japan, and many countries. We have communications and collaborations. It is not fully market-oriented technology yet. Liquid crystal engineering are now in development, and helpful solutions with potential for the market are already proposed. I can mark liquid crystalline application, for example, intellectual holosteric reflector and alignment layer for transparent electrode, and many different applications all over the world. Next steps. The market requires well-developed material and technologies. Over 50 different groups all over the world are in the subject. And it is desirable to cope with different international group organizations for testing of extractive properties of nanotube with potential of different applications. It can include organization of research and development communities involving different funding organizations. There are several groups actively involved in similar problem in Ukraine, mainly from Kyiv, Lviv, Kharkiv, and Odessa. It's already in close collaboration. And our group can propose new mixtures, new materials, and different types of organo-modified platelets and mixtures of good and bad solvent for their implementation. Thanks for your attention, and it's our contact information.